Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. This time we're talking about the week of October 31, 2022, so basically the first week of November. And we're going to start this week by looking at Tuesday evening, November 1st. So on November 1, as it gets dark, Capricorn will be high in the sky, not as high in the sky as it gets. We talk about the meridian being the line that connects north-south directly overhead. And as it gets dark now, Capricorn is on the meridian, straddling the meridian, so it's highest in the south that you can see. You go out on the evening of the 1st, and as it gets dark, the moon will be right there. So the moon is in Capricorn, and the moon will be something on the order of 60% full. So over half full, but less than 3/4 full, or 2/3 full, will be the moon. And the moon, Saturn has been in Capricorn for a very long time, and we've talked about Saturn there, and we've talked about Capricorn, the stars of Capricorn with Saturn there a number of times. And the moon will be about 5 degrees south of Saturn, maybe just a little bit east of Saturn there, south and east. And so So you go out, you see the bright object, the bright star-like object that's above the moon, that's Saturn. So great, as it gets dark on Tuesday evening on November 1st, go out and check this out. Look for the moon sitting about 5 degrees south of Saturn right there. The moon is near the star Zeta Capricorn, so see if you can find Zeta there. You might need binoculars. Zeta's not terribly bright. It's easy, you can see it for sure under dark skies, but with a 2/3 full moon or a half full moon sitting right next to it, that makes it harder to see it, of course. The two bright stars in the tail of Capricorn, the Neb al-Ghaiti, tail of the goat is how we translate that from Arabic, and Nashira, sit right here. Then we can step out. Let's as a couple of, sometimes we've talked about this time of year as a horn of plenty, a cornucopia here, stepping out from these stars. So we have a branch that comes out to the south that goes through Zeta and then on to some fainter stars down that direction. As we step out to the upper branch like this, we come to Iota. And Iota, we're going to stop and talk about it. And then we stretch on out to Beta and Alpha up this direction. And that's Capricorn that we've drawn in there. And so we're going to look at Iota. Iota is sitting just half a degree, a little bit less than half a degree below Saturn. So Saturn's making a really tight pairing with Iota right now. Remember, you hold your finger up at arm's length, and that's about a degree. And so we're talking about just really close. Again, Iota is a 4th magnitude star. Without the moon in the area, under dark skies, you should have no trouble finding it. You might have a little bit of trouble with this 60% full moon sitting 5 degrees below it, but you might not. You might be able to see it without any optical aid. For sure, a pair of binoculars is going to bring that right out. You're going to see this wonderful little dot next to Saturn. So this is a great marker. We've been talking about, last week we talked about Mars moving through Taurus and how you want to be able how fun it would be to track Mars, the motion of Mars as it moves through Taurus. With Saturn sitting so close to Iota, this is a great chance to go out every night for a while here, just after dark. So you don't have to stay up late to do this. You just go out after dark and make a little sketch of what it looks like, the separation between Iota and Saturn and the relative orientation of Iota and Saturn. And you can get a sense of Saturn's motion, slow as it is, through Capricorn, maybe. But we're going to talk about Iota here in just a moment, because Iota, this year, just in the last several months, a paper was published that looked at brown dwarfs, objects that are substellar. So that would have been the title of the paper, was Substellar Objects Discovered Around Other Stars. And so these are things that are bigger than Jupiter, many times the mass of Jupiter, but not big enough to be a star. Whether we call that where that break line is, we're not going to get into that right now. Whether we would call that a giant planet or whether we would call that a brown dwarf, whatever that is. But 2 of these were discovered around Iota. And we're going to talk in the astronomy class today, as I'm filming this, we're going to talk about the Doppler shift. As a star moves toward you, the spectral lines, the spectrum, the light of the star is shifted toward the blue, and as the star moves away from you, the lines are shifted toward the red. The light the star is emitting is shifted toward the red, and so you can get a sense of a star moving toward us and away from us from the gravitational attraction of objects orbiting around it. And that's how these objects were discovered. That's how the first exoplanets were discovered about 30 years ago now is what it was. And so it seems like yesterday to me, but we won't go down that road too far. About 30 years ago, we discovered the first planets around other stars using this Doppler shift method. Again, you're here, and you're looking up. That's you, looking up this direction, and there's the star. When the object's on this side of the star, it pulls it a little bit towards you. And when the object's on that side, it pulls it a little bit away from you. So the star's wobbling back and forth. It's going blue shift, red shift, blue shift, red shift. And so you see that Doppler shift, and that's how these were discovered. Since this time, 30 years ago, when we first discovered exoplanets this way, we've developed the ability to do a pretty good job of measuring the light. If a planet passes in front of a star, it blocks a little tiny bit of that star's light. And so we call that photometric detection, as this is called radial Doppler shift detection. And so photometric detection this way has become more of the standard of the way to detect many objects like this, as we've become very good at it, to see the light as that star passes down. So as that planet, passes in front of the star, you'll measure the brightness of the star, and right there, where the two edges meet, the star is going to start to get ever so slightly dimmer until it crosses and then starts to come out on the other side, and then it's going to get ever so slightly brighter. And that little dip we can measure and see that something dark has passed in front of there. And so that's a more common way today. We couldn't do that 30 years ago. We can measure star brightnesses dipping that way. But anyway, as you look at Iota, recognize that we just discovered two companions around Iota this year using the Doppler shift method of these super Jupiters. Pulling on Iota and pulling it towards us and away from us and towards us and away from us. And it was in a paper with a bunch of other stars, so sort of a catalog of objects that have appeared in these in this surveys of Doppler shifts that way. So that's what we got. Go out November 1st. The moon will be right there. And the moon's tracking to the east, of course. That's what it does. And so the moon will track away from there. It'll get fuller, so it's going to get brighter and wash out more of the sky. But maybe a night later, the moon has moved over here. You might have an easier chance seeing Iota without optical aid. So it's worth going out and paying attention to this over the next few weeks anyway. And see if you can measure Saturn moving relative to Iota. Watch the moon track through here. Think about Iota relative to these super Jupiters that were discovered, these brown dwarfs that were discovered around Iota. Just this year. They're published just this year, the discovery. By November 4th, the moon will have moved over this direction and be sitting underneath Jupiter. So by now, it's over 85% full. It was about 60% full, not quite 60% full here on the 1st. By the 4th, it's going to be 87, 88% full, and it's going to be sitting about 3.5 degrees southeast of Jupiter. And so Jupiter, now this is going to be east. If you go out just at dark, it's going to be east of where you were looking to see Saturn. If you wait a couple hours, it's going to be moving. It's going to be more or less south. That you would see it replacing where Saturn was in the sky when it got dark a few hours later. But as it gets dark on the evening of the 4th, you'll be able to see the moon sitting near Jupiter over in the southeast. So we're looking southeast right now. Jupiter will be the biggest, brightest star-like object in that region of the sky. So you go out, you see Jupiter shining big and bright. You'll see the moon sitting below there. The moon has filled out. So that's what we got. We got the moon dancing by Saturn and Jupiter this week. Take a little bit of time to explore Capricorn and see if you can see the stars of Capricorn and think about Iota Capricorni there. And that's it. And I hope you have a great week, and I hope you have clear skies. And as always, thanks for watching, everybody.